welcome back to Spring into Math 7. I'm Mrs. Campbell. Today, we're going to be talking about two-step equations. Let's jump in. All right, let's talk about how to solve a two-step equation. So we've seen that in order to solve for an unknown variable, we can isolate it on one side of the equal sign and evaluate the numbers on the other side. In this chapter, we're going to expand our ability to do that with problems that require us to combine more than one technique to solve for the unknown. Let's jump right into an example. Rebecca has 3 bags containing the same number of marbles plus 2 marbles left over. She places them on one side of a balance. Chris, who has more marbles than Rebecca, added marbles to the other side of the balance. He found that with 29 marbles, the scales balanced. How many marbles are in each bag? And assume that each bag weighs nothing. Here's our solution and a picture. We know that the system balances, so the weights on each side must be equal. We can write an algebraic expression based on this equality. The unknown quantity, the number of marbles in each bag, that's going to be our x. And we can see that on the left-hand scale, we have 3 bags, each containing x marbles and 2 extra marbles. On the right scale, we have 29 marbles. The balancing of the scales is similar to the balancing of the following equation. 3x plus 2 equals 29, which means 3 bags plus 2 marbles equals 29 marbles. All right, so to solve for x, we need to first get all the variables or the terms containing x alone on one side. And we're going to aim to get all the constants on the right, leaving only the x on the left. Okay, we have 3x plus 2 equals 29. We subtract 2 from both sides. We get 3x equals 27. All we do here is divide both sides by 3. 27 divided by 3 is 9. So now we know there are 9 marbles in each bag. Okay, another example. 6 times x plus 4 equals 12. Okay, this equation has the x buried in parentheses, so we have an option. We can either distribute the 6 on the left or divide both sides by 6 to remove it from the left. Now, since the right-hand side of the equation is a multiple of 6, it's 12, it makes sense to divide. So 6 times x plus 4 equals 12. So all we're going to do to get rid of that 6 is divide both sides by 6. The 2 6's cancel out. And we get x plus 4 equals 2. Then we just subtract the 4 from both sides. We get x equals negative 2. So two-step equations are just like one-step equations. You just do 2 of them. Another example, solve x minus 3 over 5 equals 7. Okay, so this equation has a fraction in it. Don't panic, it's not that hard. It's always a good idea, though, to get rid of those fractions first. So we have x minus 3 over 5 equals 7. So all we have to do to get rid of that 5 is multiply both sides by 5. Okay, which gives us x minus 3 equals 35. Then we add 3 to both sides and we get x equals 38. See, it's not really so hard at all. Here's another example. Solve 5 over 9, x plus 1 equals 2 over 7. So first we're going to cancel the fraction on the left, making the coefficient equal to 1 by multiplying by the reciprocal, or the multiplicative inverse. So we're going to multiply both sides by 9 over 5. Okay? These cancel out, leaving us with x plus 1. This multiplies to 18 over 35. Okay? Then we're going to subtract 1 from both sides. And I just changed my 1 into 35 over 35. So we could subtract the fraction. And 18 over 35 minus 35 over 35, or 18 minus 35 over 35 equals negative 17 over 35. So, like I said, these examples are called two-step equations because we need to perform 2 separate operations to the equation to isolate the variable. All right, let's talk about solving a two-step equation by combining like terms. When we look at linear equations, we predominantly see 2 terms, those that contain the unknown variable as a factor and those that don't. So when we look at an equation that has an x on both sides, we know that in order to solve, we need to get all those x terms on one side of the equation, one side of the equal sign. This is called combining like terms. Now they're like terms because they contain the same variable or the same combination of variables. And I've given you some examples here. I won't read them all. You can pause your video if you'd like. But negative 17x, 12x, negative 1.2x, and 17x over 9, those are all like terms. And you can see the rest, some other examples there with the variable y and xy to see what are like terms. Here's some more examples of unlike terms. So the opposite, these are different. Negative 3x and 2y, unlike. Negative 12xy and 2x, unlike. Negative 0.001x and 0.0001, not like. So to add or subtract like terms, we use the distributive property of multiplication instead of addition and subtraction. So look at this example here. 3x plus 4x is the same thing as 3 plus 4 times x equals 7x. 0.03xy minus 0.01xy is the same thing of 0.03 minus 0.01 times xy, which would equal 0.021. And there's two more examples there that I'm not going to read at this minute, but feel free to pause your video and see if you can figure out how to use the distributive property there. Okay, to solve an equation with two or more like terms, we need to combine them before so we can solve for the same variable. Here's one that says solve x plus 5 minus 2x minus 3 equals 6. So there's two like terms, x and negative 2x. Now remember, the negative sign multiplies everything in the parentheses. Collecting like terms means we write all the terms with matching variables together. Then we will add or subtract them individually. So we pull out the x from the first bracket and the negative 2x from the second bracket, and then we rewrite the equation collecting like terms. So it ends up looking like this. X minus 2x plus 5 minus negative 3 equals 6. So all I've done is combined those two terms and those two terms. And then I simply solve. So I've done here, worked in the parentheses, 5 minus negative 3 is 8, and the x minus 2x gives me negative x plus 8 equals 6. Subtract 8 from both sides, and I get negative x equals negative 2. Then I'll multiply both sides by negative 1 to isolate the variable, and our solution is x equals 2. Here's another example. Solve x over 2 minus x over 3 equals 6. So this problem involves fractions, and combining the variable terms will require dealing with fractions. So we need to write all the terms on the left over to a common denominator of 6, which is actually not that hard. So we have now turned the problem x over 2 using our common denominator of 6 now becomes 3x because I have to multiply the denominator and the numerator by 3. And x over 3 becomes 2x over 6 because I had to multiply both by 2. And next we just combine them and then we subtract them. 3x minus 2x gives us 1x. Denominator 6, so we get x over 6 equals 6. We're going to multiply both sides by 6 and we get x equals 36. Okay, let's solve real-world problems using two-step equations. Okay, when we're faced with real-world problems, the thing that gives people the most difficulty, I'm going to highlight this so you remember it, is going from a problem in words to writing it out as an equation, and it is a little intimidating. But first, all you need to do is look what the equation is asking. What's the unknown? Do that first. What do you have to solve? And that's going to determine the quantity we will use for our variable. So the text, or the question itself, explains what's happening. You need to break it down into small, manageable chunks, then follow what's going on with our variable all the way through the problem. Here's an example. An emergency plumber charges $65 as a call-out fee plus an additional $75 per hour. He arrives at a house at 9:30 to repair a water tank. If the total bill is $196.25, at what time was the repair completed? We got a lot of information in there. So we just need to organize it and find what we're looking for. So here's the question. This is just the question again rewritten, so we have it. So in order to solve this problem, we're going to pull out all that information and write it in an equation. What we're looking for is the time taken in hours. That's going to be our X. The bill is made up of two parts, a call-out fee and a per-hour fee. The call-out is a flat fee, and it's going to be independent of X. The per-hour part, though, will depend on X. So let's look at this algebraically. $65 as a call-out fee, we'll just say that's 65, plus an additional $75 per hour, we'll call that plus 75X. Okay, there's the problem again written, what we've done so far. So the bill is made up from the call-out fee plus the per-hour charge. So this creates the following equation. 65, the total bill, equals 65 plus 75X. Lastly, we look at the final piece of information, which is the total bill. It was $196.25. So our final equation is $196.25 equals 65 plus 75X. Now we just solve for X. So the first thing we're going to do is write it out. 196.25 minus equals 65 plus 75X. To isolate X, we're just going to subtract 65 from both sides. We get 131.25 equals 75X. We're going to divide both sides by 75. We get 131.25 divided by 75 equals X. Once we do that division, we find that the time taken was 1 3/4 hour. And we can change that into 1 hour and 45 minutes. So if he arrived at 9:30 and he was there for 1 hour and 45 minutes, then the job was completed at 11:15 a.m. Okay, so in this lesson, we've learned that some equations require more than one operation to solve. Generally, it's good to go from the outside in. If there are parentheses around an expression with a variable in it, cancel what's outside the parentheses first. Terms with the same variable in them or no variable in them are like terms. Combine like terms, adding or subtracting them from each other to simplify the expression and solve for the unknown. All right, everyone, that does it for this lesson. Thanks so much for joining us, and we'll see you next time. Bye-bye.